Hi, I am Tatsuya Ishigaki. In this short presentation, I present our paper entitled Semi-Supervised Extractive Question Summarization using question-answer pairs. In this research, we focus on the task of extractive question summarization. Recently, many people use community question answering sites. These sites tend to display the first sentence as the headline, but they do not necessarily represent the most important part of a post. As shown in this example, the author of this post explains some background information such as the type of iPhone or the availability of Wi-Fi at his home. The core part of the question is shown in the later part of the post, and we want to show the most important sentence as the headline. So we deal with the task of extractive question summarization. In this task, the input is a question post, and the model outputs a single sentence summary that represents the most important part of the question. Previous approaches for this task are mostly supervised. For example, Tamura et al. Proposed a feature-based classifier, and Higurashi later proposed a learning-to-rank approach. Recent neural network-based approaches are not specifically designed for question summarization, but we can apply these models for this task if we have a large annotated data. Of course, one of the disadvantages of these supervised approaches is the need for costly annotated data. In this research, we investigate how we can use question-answer pairs for training question summarizers. Next, I explain our semi-supervised setup. In our setup, we use question-answer pairs in addition to manually annotated questions. So we assume that we have two datasets, label and pair. Label is a small dataset with costly annotated sentences. Pair is a large dataset with question-answer pairs. We can obtain a large number of question-answer pairs from a community question answering site. Training summarizers on these two datasets can be seen as a semi-supervised setting. This example shows an instance in pair dataset. The question is about setting up iPhone without Wi-Fi. You will note that some important words such as iPhone or Wi-Fi are also included in the answer part. So we came up with an idea to additionally use question-answer pairs to improve the performances of summarizers. This slide shows our framework to use question-answer pairs. This framework consists of two components, sentence extraction model and answer generation model. Sentence extraction model is the main component for scoring sentences. Word encoder first read every word in a sentence and outputs sentence representations. Then sentence encoder reads the sentence representations. We use bidirectional LSTM for the encoders. Finally, a linear layer scores every hidden state, and a softmax function converts them to probability distribution. Then answer generation model generates an answer of the input question by using an encoder-decoder with an attention mechanism. This is an auxiliary component to give information through attention weights. In every time step, this model generates a word and outputs attention distribution over sentences in the input. We believe that the model gives higher attention scores for important sentences when generating an answer. So we calculate the importance score for a sentence as the sum of the attention weights from every time step. For the experiments, we compared several methods for training our framework. The performance is measured by using the accuracy on label dataset. We calculated the accuracy as the number of correctly predicted questions divided by the total number of questions in the variation dataset. As a result, we found that using question-answer pairs improved the performance if we jointly train a sentence extraction model and answer generation model with an appropriate sampling method. For further detail, please refer to our paper. So in conclusion, we proposed a framework to use question-answer pairs for extractive question summarization. Using QA pairs works well when we apply an appropriate sampling method, and our data will be publicly available. Thank you very much for watching this video.